Okay. Hello, everyone, and welcome to our today's episode of solving the advent of code puzzle. Today is day two. And we again try it again in Go. So let's start and dive in. So our puzzle today is rock, paper, scissors. Okay, this is nice. Let's see what are the rules. The elves begin to set up camp on the beach. To decide host tents, be closest to the snack storage. A giant rock, paper, scissors tournament is already in progress. Okay, I assume all of you are more or less familiar with rock, paper, scissors, so therefore we skip this. Appreciative of your help yesterday. One elf gives you an encrypted strategy guide. Okay, this sounds interesting. That they say will be sure to help you win. The first column is what your opponent is going to play. Okay, we have a mapping here from a name, from symbol to the action. So A for rock, B for paper, C for scissors. The second column, suddenly the elf is called away. Okay. The second column, your reason must be what you should play in response. X for rock, Y for paper, Z for scissors. Winning every time would be suspicious, so the responses must have been carefully chosen. The winner of the whole tournament is the player with the highest score. Your total score is the sum of your scores for each round. The score for a single round is the score of the shape you selected. One for red. Oh, okay, so the shapes have different values. This is nice. Nice to know. And the score for the plus the score for the outcome. 0 if you lost, 3 if the round was a draw, or 6 if you won. Since you can't be sure if the elf is trying to help you or trick you, you should calculate the score you would get if you were to follow the strategy guide. For example, suppose you were giving the following strategy guide. This strategy guide predicts and recommends the following. In the first round, your opponent will choose rock, and you should choose paper. Okay, based on this strategy, makes sense. This ends in a win for you with the score of 8. 2 because you chose paper and 6 because you won. In the second round, your opponent will choose paper and you should choose rock. This ends in a loss for you with a score of 1. The third round is a draw with both players choosing scissors, giving you a score of 3 plus 3. Draw, scissors, scissors, and then okay, 3 and 3 for the draw. Makes sense. Okay, so we end up with 15. What would be the total score if everything goes exactly according to your strategy guide? Okay, sounds like a doable puzzle. So, okay, we just copy our input that we get. Okay, this is quite long. We'll see. So let's go into our project. So, and add this here as a new file. Let's matchplan.txt. Okay, and here we add it into, okay, sounds easy enough. So now we need our new application. A2 package main. Okay, so how do we start? So first we should think about, okay, what are the things that we need to work with? One is basically the different symbols that we have, right? Or the different shapes of as they are called here. So therefore, I think it makes sense to define those shapes. So we have our type, we call it shape, and it's a struct. So, and what does these shapes entail? So basically they give you, they have different symbols. One symbol for the opponent and one for us. So, which means we have symbol opponent, which is of type. Do we have a character type? Oh, we just use strings. Just use strings. String. Then we have a symbol opponent and us, just say us is probably not the best name yet, but okay. And then we have a different thing, which is basically the score. So as explained, every shape has a different score that we get when we basically select it. So this means score. And this is again one int. So good enough for that. Now we need our list of different shapes. So we create our shapes and say, for example, we have a const that is rock, and this is of type shape. And then we initialize this. So the symbol rock. Okay, I think we must do this way. Is this correct? Symbol opponent, and the symbol for the opponent was the A. Symbol us is, let me check, I think it should be X. A for rock, B and for us is X, Y, and Z. Okay. And we have some score. And the score is 1. 1, 2, 3. Rock, paper, scissors. Okay. Good. This looks good. So now we need to do this in the same way. This is not right. Okay. We don't need it, and this is also not something. Const initializer is not a constant. Okay. Just make it a variable. This whole concept of what are constants, what are variables is something that I don't have fully understood yet. So, but this shouldn't stop us. So rock, paper is the next one. So B, Y, and 2. And scissors, which is C, Z, and 3. Okay, so far so good. Let's start over and think about, okay, how can we calculate or read basically our strategy book. So for this, again, I just going to reuse basically what we wrote yesterday. Where the development projects, advent of code, trust project, attach. So here we had our famous example from yesterday. Just copy some stuff that we need. So basically this part, which is basically just the reading of the file. Our file now is not the elves.txt, but the matchplan.txt. Matchplan.txt. Okay, then we need to loop over it, read it line by line, and then calculate the score. So we have a score that is initialized with 0, score 0. Yeah. Then we basically copy over this scanner so we can read it in individual lines. Okay, line, scanner, text. So we have a line, and now all these lines are separated via some space. So we need to split it and then know the individual parts, the individual scores. So line is scanner text, Okay, now the question is, how can we actually do this? So, what? Delete? No. We need this. So, looking into the Go, Golang string. What can we do with the string? Okay, this looks nice. What we need to do is basically split it. Okay, this should be simple. So we just say line dot split. I don't know why this doesn't work yet. We don't have the path ready. Why? Go. Doesn't seem to like it either. Okay, so symbols, and we take our line and split it at a space. So that maybe we should have run it directly from the start. And let's try it to just run the file and see if it works. Okay, run go build 2. And it doesn't do anything. Oh no, it ran. Oh, it ran. Okay. Okay, but why is this line not working? This is a string. And why don't... No, I'm just doing it wrong, I assume, right? We need this are functions from the string packages. Strings. No. Strings dot split. Yes, of course. I was completely doing it wrong. Okay. So now we have our symbols and we need to match them basically with the individual shapes. So for that, we just can create a function which maps the symbol that we get with the shape. So func that we call parse shape. It takes a symbol in form of a string and returns the shape. So far so good. So what we now do is basically if symbol in, if symbol equals, we can basically do this. So we loop over the existing shapes, all shapes that we have. So create a new variable, shapes, which is equal to a slice of shape, and then add their rock, paper, scissors. And we don't store them directly, but we just store the pointer to them because we don't want them to be copied over, right? It's enough if we have one instance of those shapes or around. So, and then basically what we do, we loop over this shape from shapes, range shapes, dot, again, ignore the index, shape dot symbol opponent equals symbol, symbol, and since we have two symbols, we can also directly match it there. Shape symbol us equals symbol, then return shape. So, and we should return not the shape, but just a pointer to it. Okay, so in case we don't find a valid symbol, this is something that we should create an arrow for that. So we say arrow function invalid symbol and print out, add the symbol to it. Return nil, and here we return no arrow. So we have again this. Okay, this sounds good. So now let's pass both symbols. So where we say opponent choice or symbol shape is the point, not the symbol. Shape is equal get symbol pass shape symbols 0, and we have our shape as again pass shape symbols, but the second one. Okay, now Go doesn't like this because we didn't edit the arrow. So if no, again, just panic. We don't need any sophisticated error handling here in this case. Okay, so and then maybe what we can do, just print out the match that we found basically. So we say here versus, and then we can run it and see if our parsing of the shapes looks fine. Opponent shape, our shape. So does this work? Oh, the score is still something that we don't need. Run it. Okay. And what we return here are the different symbols. So this is scissors versus scissors. Is this the first one? Yes. Then the second one, scissors versus scissors, also okay. Rock versus rock. Okay, so basically, at least to us, it looks like we are not that far off. The print F. This is again some mistake where we want to print it out. New line in string. New line argument possibly missing comma. I removed the shading. Okay. And it's not that good looking at the moment. Maybe there's some way how we can optimize that. So let's think about how we can make the output a little bit nicer, because this doesn't look really good. I'm wondering if there is some Golang implement toString. Is there something like that? ToString function. Would be nice to pass arbitrary which implement toString. Oh, okay, it's just the string. Okay, this is something that we can implement. So where we take a shape and then just, okay, let's do that. Func shape, and then the method is just called string, returns a string, quite easy. And then just settle for, okay, let's give those things a name. Name the string. And then name then rock. This is scissors, and this is paper. Okay, so far so good. And then implementing this method is quite easy. We just take the shape and return its name. Okay, now try again, and we will see hopefully something else. Yeah, this looks very nice, much nicer than before. Okay, we know scissors versus scissors, scissors versus scissors, rock, rock, rock. Okay, so fine. Good, but now we just can print the match plan. It doesn't help us to understand if the strategy is valid or not. So for this we need to find out actually what is the score. And for the score we have two different sources. One source for our score is basically what we chose. So we can directly, for every match that we have, add to this final score basically the score of the symbol that, or of the shape that we had. So we just do this here and say, okay, score equal plus, is this something that works? We see our shape dot score. Okay, looks good. And then in the end we print out the final score. Final score. And we have here. So now let's calculate this as a first. Our final score 4,808. Okay, but this is just the score that we get from our shape, right? That is taken from this. The more important score is basically the score that we get from the matchup against our opponent. So if we win or if we lose. So for this we would need to figure out if we win or if we lose. And this is something that we can decide based on the shape. So we know for this we need some method that tells us actually if we win or if we lose. And this is something that we can implement in an own function where we say func, and we call it, how do we call it? Get game result or calculate result. And it takes two shapes. Shape 1, which is of, and shape 2, which is, and then it returns basically if this is a draw, if or it should return that. So we just say that we create some own class or type for that, which is our result. So then, okay, we need to define this type. So how do enums work within Go? So just a quick check. Enum, probably it's an, okay, doesn't look that hard. You make consts. Enum types. No, there are types for that. Okay, this makes more sense. This makes more sense, where we say, okay, we have our type, and then we can define also the score directly as, hopefully, as the value of the individual types, of the individual. Yeah, okay, let's try. So we have our, it's not season, but we have our result, and we call, I think it's just an int. Then we have lose, where we get 0 points. Makes sense. Then we have draw, where we get 3 points, and we have a win, where we actually get 6 points. At least this was what I remembered. Let's check again. So how does this work? 0 if you lost, 3 if your round was a draw, and 6 if you won. Okay, yeah, this sounds reasonable. So now it's time to discover how to calculate actually who won. That's their shape. Rename those so it's clear basically which one is the one relevant for us. So if we know that basically, do we have something like switch expression shape, their shape, if their shape, okay, then case let's try, does this work in this way? Okay, and then we can do here again a switch case, switch our shape. When rock versus rock, we return result. Oh, there's something that I didn't understood about this, obviously. Ah, okay, I need to... Season type with int as the base type. This defines the boss. I should have to achieve the same result in a more reasonable. Okay, so this means this is not correct. Here we also need the result. Okay, and then here we basically lose. No, rock versus rock is a draw, right? So it's a draw. So in case we got paper, return, so rock is beaten by paper, so basically we win. And case scissors, rock beats scissors, so we lose. Okay, easy enough. Let's implement those for the other cases. So their shape is not rock, but paper. So, but we have rock. So this means their paper beats us, so we lose. Both have paper, it's a draw, and their paper is beaten by our scissors, since we can cut it, so we win. Okay, this for that, and then now the only missing part is what happens with when they choose scissors. And again, we have rock, So our rock destroys their scissors, we win. Our paper is cut, we lose. And our scissors and their scissors end up in the draw. Okay, looks fine. Let's try to calculate this and add this. So if we now say we also add their plus calculate result, opponent shape, our shape, and what do we see? Mismatch. Okay, can we cast this to an int? It seems we can. Yeah. Okay, we are still doing those mix-ups. Oh, okay, now we need to add everywhere that we compare the pointer to it, because we want to make sure it's about it's the same instance. This is correct. And we have an error here because we don't return. Here we should need to return an arrow actually. So should we return arrow? We just return 0. Okay, let's see what happens now when we run it and what is our final score. 14,400. Okay, let's do a spot check and see if the matchup that we actually calculated is actually correct. So if our wins are actually wins. So we can win match score, just print it out, and then we can easily see if this is actually something that see if this is actually the correct result in the end. So how many points do we get for the individual score? Match score. And run through it. Okay, scissors versus scissors is a draw. Makes sense. Scissors versus paper is 0 because we lose, it's our paper. Scissors versus rock. This looks good. Our rock beats their scissors, so 6 sounds about right. Paper versus scissors, 6 points for us, also right. Scissors versus rock, 6 points. Paper versus paper is a draw. Rock versus paper is looking through it. It looks kind of we are winning quite a lot. So I would argue that that the strategy is not that bad. At least let's see if this is basically everything what we needed to do. So what would be the total score if everything goes exactly according to your strategy guide? So didn't we miss anything? We have the score in it. We have the score that we get for the individual shapes in it. 1 for rock, 2 for paper, 3 for scissors. So I think we could be quite sure and say, okay, something else we missed. No, this is we have an end in the end, so our final score is, let's check it, if this is actually correct, what we calculated. Yes, okay, so another day, another solution, nice. Okay, let's take a look at what is part 2. The elf finishes helping with the tent and sneaks back over to you anyway. The second column says how the round needs to end. X means you need to lose, Y means you need to end the round in a draw, and Z means you need to win. Good luck. Okay, so this is a little bit different now. You need to lose means you need to end the round in a draw, and that means you need to win. Good luck. The total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. The example above now goes like this. Okay, so we need to change it. So it's no longer that we have different symbols, we have only one symbol. And then we have a symbol not for a shape, but for the result, right? So we have our result, and then we need to implement some mapping here. So then what we can do, just basically change this into something else, go away from this, and we make it also a struct, which has two different fields. One would be the symbol, which is a string, and the other one would be basically the score that we get from the result, which is an int. Okay, and then we would need to define our results in the same way as we basically defined the shapes. So we say here we have a result which would be a lose. This is a result where the symbol, okay, let's take a look at the mapping. X means you need to lose. Okay. Symbol is X. And our score for lose is 0. Okay, then we create the same thing. No. What is the problem here? Probably because we have multiple of the same instances, right? Redeclared. Yeah, okay, this is true. This is not how it should be, but we will remove it in the end. So then we have a draw. A draw has which symbol? A Y. And we have and then again we have a win. Win means symbol is then that, and the score of a win is 6. Okay, now we can remove that. So now we need to adapt some other code as well, right? Because there's still this, here we return a result, but we should return we'll return a result. We'll return as a default, we return lose. So, okay, but now the parsing doesn't work, right? Because we shape here from multiple things. So instead of parse shape, we also need something that parses the result. So parse result, where we get a symbol, result. Okay, let's do it the same way. Say our results are always unique items, so we need to always return a pointer to them, to the values. Okay, parse result. So we have our results, which is again something that we need to build. Move this over and say these are the shapes, these are our results. result, lose, draw, and win. So, and in pass result, basically we check if result, if the symbol for this result is equals to the symbol that we got here, then we can return the result. Otherwise, we just return an error again. Okay. Then we need to get rid of those symbols here, because as we know, there's only one symbol for each shape. So remove them. Okay, and then we can move this whole branch. This is no longer necessary. Okay, let's look how we do this. So we pass the shape, we pass the result from the other symbol. And then we need to figure out that result. We need to figure out from our expected result how to map this, or what shape we should actually we should return, basically. So this means this calculate result is something that we don't need anymore. Instead, we calculate not the result, but we recalculate our move or our shape based on a result. So calculate shape, their shape, expected result, result, and then we return our shape. So now let's exchange it. So if we say we expect the expected result when our opponent plays rock and the expected result is a draw, then we should also play rock. When the expected result is a win for us, this means we should play paper. And if the expected result is that we lose, then we should play scissors. So far, so good, I would say. But there's something wrong here. Let's see what is wrong. Invalid case, draw and switch. This was the problem. So, okay. Since expected result is already a pointer, we just need to compare it to the address to the individual values. Okay, so this is what we change here. So now that we do the same in the other cases where we say the expected result is a lose against paper, then we should play rock. If it's a draw, we also should play paper. If we should win, we need to play scissors. And in the same way, we are just changing how it goes here. So if we want to win against scissors, we need to play rock. If we want to lose, we need to play paper. If we want to achieve a draw, we play scissors as well. And otherwise, we just, to make the compiler happy, we just always play rock. Let's say it that way. So now we have our calculate shape method, which tells us, based on the expected result, what we actually should do. So therefore we say, okay, we have here our move or our shape. Our shape is then calculate shape based on opponent shape and based on expected result. And then we can use the same code again, calculate the result. This does no longer work because the result has now the score as an attribute instead. So basically we calculate the score based on we get the score as an attribute from our result. But maybe we should compare them and make sure that our result is actually what is the expected result. Maybe this could help us to find out some errors. So let's implement this, or basically check this first. If result not equals expected result, then panic, we create an error where we say result not as expected, because as everyone who is basically tinkering and forwarding results, we should make sure that this is happening as expected. So let's see if this works. We run it. Okay, our final score is less. Okay, there are a lot of here are more wins again. I'm currently not sure if this is actually the better strategy. From looking at it, if I just skim over it and compare the numbers of 6s and 0s, then it might be a problematic move to use this. But okay, this is basically what the elf told us. So let's see if everything goes according to your strategy guide. Let's see if we didn't miss anything. So the first round, your opponent will choose rock and you need the round to end in a draw. So you also chose rock. What we could do, we can basically try and check this example to make sure that we are actually doing what is expected from us. So create a new file, test.txt, and then we build this as expected. We write it here from the browser. We have the and write this into a test method. So our opponent chooses rock and we are expected to lose, to end in a draw. Then this should give us 4. In the second round, our opponent chooses B and we choose rock, so you will lose. So we will lose, which is X. And the third round, your opponent will defeat, you will defeat your opponent's scissors. Scissors is C, and we will defeat, so that, with a score of 7. Okay, so if we now run this on our test file, test.txt, we should end up with 14. Our final score is 12. Now that you're currently decrypting the ultra top secret strategy guide, you should get a total of 12. Okay, so seems like this was the correct one. So then again, calculate our match plan, run it, and end up with 12,382. Submit. Yes, and we have a answer again. Okay, that was it then for today. Thank you for joining, and we'll see us tomorrow when we take a look at puzzle 3 for day 3. Bye everyone.